The barycenter, also known as the center of mass, is a crucial concept in physics, particularly in celestial mechanics. The barycenter is the point in space where the weighted average of all the masses in a system is located. It is the balancing point where the system would balance if it were supported there. It is the point in space around which two or more objects orbit when they are gravitationally attracted to each other. As a result, the two bodies effectively orbit around a common point, which is the barycenter. It is the point in space around which two or more objects orbit when they are gravitationally attracted to each other. This concept was first described by Isaac Newton in his groundbreaking work, Philosophiae Naturalis Principia Mathematica, published in 1687. This concept was fundamental to Isaac Newton's understanding of planetary motion and his development of the laws of motion and universal gravitation. The third law states that for every action, there is an equal and opposite reaction. In the case of two celestial bodies, each exerts a gravitational force on the other. These forces are equal in magnitude but opposite in direction. Here are some key points to remember about the barycenter and Newton's laws. Location: the barycenter is always located between the two objects. Its exact position depends on their relative masses. A more massive object will be closer to the barycenter. Orbit: both objects orbit around the barycenter. However, the path of the less massive object will be more noticeable. For example, the Earth orbits around the Sun, but the Sun also orbits around the barycenter of the Earth-Sun system, although its movement is much smaller due to its greater mass. Newton's third law: the equal and opposite forces between the two objects ensure that they both orbit around the same point. Applications: the concept of the barycenter is essential in understanding the motions of planets, stars, and galaxies. It is also used in spacecraft navigation and the design of satellites. 1. Newton's first law of motion. This law states that an object at rest will remain at rest, and an object in motion will remain in motion with a constant velocity unless acted upon by an unbalanced force. In the context of celestial bodies, the barycenter is the point around which the objects revolve, maintaining a constant velocity. 2. Newton's second law of motion. This law states that the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. The barycenter is the point where the net force on both objects is zero, ensuring that they both accelerate towards it. 3. Newton's law of universal gravitation. This law states that every particle in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. The barycenter is the point where the gravitational forces between the two objects balance, resulting in their mutual orbit. Examples of barycenters: Earth-Moon system. The barycenter of the Earth-Moon system is located approximately 4,671 kilometers from the center of the Earth. This means that the Moon does not orbit the Earth's exact center, but rather orbits a point slightly off-center. Binary star systems. In binary star systems, two stars orbit each other around a common barycenter. This can have significant effects on the evolution of the stars and the formation of planets. Importance of barycenters. Understanding planetary motion. The concept of the barycenter is essential for understanding the motion of planets and other celestial bodies. It helps to explain why planets do not simply fall into the Sun, but instead orbit around it. Space exploration. Understanding barycenters is crucial for planning space missions, as it helps to determine the trajectories of spacecraft and the gravitational forces they will encounter. Astronomy. Barycenters are used in astronomy to study the properties of binary stars, exoplanets, and other celestial objects. In conclusion, the barycenter is a fundamental concept in physics that has played a crucial role in our understanding of the universe. It was a key component of Isaac Newton's work on motion and gravitation, and it continues to be important in fields such as astronomy and space exploration.